Good morning students. Dear students, in the previous video, that is on yesterday, we had discussed about certain numericals based on significant figures, how to identify the significant figures in the given measured values, and also we had rounded off the given certain quantities up to 2, 3 or 4 decimal places, how to round off the measured values according to our convenience. We had discussed in the previous video. Now today we will discuss certain numericals, two or three numericals we will discuss today. That is the last part of this chapter. So look at here, one numerical is in front of you. Try to solve the numerical, and after solving that numerical you may see the solution. Press the pause button, and after that try to solve that question. So here the given question in front of you is that it is claimed that two cesium clocks, if allowed to run for 100 years, the atomic clock, that is cesium clock, is allowed to run for 100 years free from any disturbance. There is no disturbance, there is no any type of air resistance, it is free from any type of disturbance. After both the clocks running for 100 years, after running for 100 years, they differ. Both the difference between the readings of both the clocks is 0.02 second. What does this imply for the accuracy of a standard cesium clock? Is measuring a time interval. If both the clocks are measuring a time interval of 1 second, then what it implies about its accuracy? So we will solve this question in two ways. First, we will try to solve on the basis of significant figure, and after that we will solve it on the basis of error analysis. So look at here. Time interval of 100 years. Time interval of 100 years. Time interval of 100 years. Time interval of 100 years, it can be expressed as 100 into 365.25 into 24 into 60 into 60 second, and it will be 315576123 second. This will be time in second. Difference in two clocks. Difference in two clocks. It is given in the question, that is equal to 0.02 second. It is the difference between. So measure time interval in second. Measured time interval in measured time interval in second means it will be equal to 315576000.02 second, or 315576000.98 second, because the difference is that to either it is more or less by 0.02 second. Both these values of measured time contains, these two values contains how many significant figures? Both contains 12 significant figures. Both this quantity contains 12 significant figures. So accuracy of standard accuracy of standard cesium clock is accuracy of 1 part of in 10 to the power 11 to 10 to the power 12. Accuracy of standard cesium clock. Accuracy of a standard cesium clock, 1 part of 10 to the 1 part of in 10 to the power 11 or 10 to the power 12. One part in 10 to the power 11 to 10 to the power 12. Now the second way to solve the question alternatively, the second way to solve this question is delta t is equal to 0.02 second. So it is equal to 2 into 10 to the power minus 2 second. T is equal to 100 years. It is equal to 3.1557634 second. Okay. Or you can write it as 3.15576 into 10 to the power 9 second. In scientific notation, so relative error, in terms of error, relative error, it is equal to delta t upon t. Relative error is equal to delta t upon t. So delta t is what? 2 into 10 to the power minus 2 second upon 3.15576 into 10 to the power 9 second. And it will give the result 6 into 10 to the power minus 12. Approximately the range will lie 10 to the power minus 11 to 10 to the power minus 12. This is the order of magnitude, 10 to the power minus 11 to 10 to the power minus 12, which we had studied before. That is the order of magnitude, and the order of magnitude is 10 to the power minus 11 to 10 to the power minus 12. Means accuracy will be, accuracy in this case is approximately equal to 1 upon 10 to the power 11 to 1 upon 10 to the power 12. One part in 1 upon 10 to the power 11 to 1 upon 10 to the power 12. This is the accuracy. So in two ways we had solved this numerical. Now the second numerical is length, breadth and thickness of a rectangular sheet of metal. Length, breadth and thickness. Length is equal to 4.234 meter. Breadth is equal to 1.005 meter, and thickness thickness is equal to 2.01 meter. Give the area and volume. You have to find area and volume. Area and volume of the sheet to correct significant figures. You have to find area and volume to correct significant figure. 2.01 centimeter. It is given as thickness is given in centimeter. So we have to convert it into meter. So length, width and height, area of the sheet, 2 into length into width plus width into thickness plus length into thickness. And since we have to see the least significant figures, so 3 significant figures, least significant figure 0.00201. So it consists of 3 significant figures. So we have to describe the result, we have to mention the result, we have to code the result in 3 significant figures. Clear? So now we are going to solve this question. Look at the solution. Look at the solution. Answer. Length is equal to 4.234 meter. Width is equal to 1.005 meter. And thickness is equal to 2.01 centimeter. That is equal to 0.0201 centimeter. 0.201 meter. Now area of the sheet. Area of the sheet is equal to 2 into length into width plus width into height plus height into thickness. That is equal to 2 into 4.234 into 1.005 plus 1.005 into breadth into thickness. Breadth into thickness. So 0.00201 plus height plus length into thickness. Length into thickness. So length is 4.234 into 0.0201. Sheet is in the form of cuboid, so we are finding the area of the cuboid. 2 into length into width plus width into thickness plus length into thickness. All the values we have written here. It is meter square. So we get the value 2 into 4.25517 plus 0.020205 plus 0.085134 meter square. And from here we get 2 into 4.360473 meter square. And here we get 8.7209478 meter square. 8.7209478. Now we have to mention the result up to 3 significant figures, because here we are getting only 3 significant figures, that is the least precise value. And as we had studied that in arithmetic calculations, in the result the number of significant figures consist number of significant figures in the result is the least significant figure in the measured values. So here in the thickness only 3 significant figures, so only 3 significant figures are allowed in the answer, and it will be 8.72 meter square. I hope it is clear to all. Now volume of the sheet. Now we will discuss about volume of the sheet. This is about area of the sheet. Now volume of the sheet, length, breadth into thickness. Length, breadth into thickness. Volume of the sheet. Volume of the sheet is equal to length into breadth into thickness. Length is 4.234 meter into breadth into 1.005 meter, and thickness is 0.0201 meter, and we will get the result. It is in meter cube. We will get the result 0.08555289 meter cube, and we have to mention the result up to 3 significant figures. So the result will consist 0.0855 meter cube up to 3 significant figures. Now the next question. The mass of a box. All the calculations here in arithmetic operations, as we had studied, all the calculations are similar what you had done before, but you have at last in the result you have to take it in the mind that we have to mention the result only in the least precise value. Whatever the least precise value, least significant figures in the measured value, the result will be expressed in the same least number of significant figure or least precise value in the measured quantities. Mass of a box. Mass of a box. Mass of a box measured by grocer's balance. Grocer's balance is 2.3 kg. 2 gold pieces. 2 gold pieces of mass is 20.15 gram and 20.17 gram are added to the box. What is A, the total mass of box, and B, the difference in masses, the difference in masses of the pieces to correct significant figures. To correct significant figures. Both here in the question, mass of the box is 2.3 kg. 2 gold pieces of mass is 20.15 gram and 20.7 gram. First of all, we have to convert it into kilogram. and then we have to add all the three masses. Then we will get the total mass, and after that the difference of masses between both the gold pieces we will calculate. So look at here with the solution. Mass of the box, mass of the box 2.3 kg, mass of one gold piece 20.15 upon 1000 kilogram, and it is equal to 0.02015 kilogram. Mass of other gold piece is equal to 20.17 kg upon 1000, and it is equal to 0.02017 kg. These are the two masses. So total mass of the box, total mass of the box 2.3 kg plus 0.02015 kg plus 0.02017 kg, and it will be 2.34032 kg. Now we have to give the calculation for up to 3 decimal places, up to 2 decimal places, only up to 2 decimal places. So it will be 2.3 kg. Means in the final result we are not getting the masses of gold pieces are ignored. Masses of gold pieces are ignored, and the approximate value of the box is only 2.3 kg. Now difference in mass of the pieces. Difference in mass of the pieces. Difference in mass of the pieces. Difference gold pieces. What is the difference? Is 20.17 gram minus 20.15 gram, and it is equal to 0.02 gram. So that's all for today, students. Write one numerical for homework and giving you as home assignment to do it. And in tomorrow's class, I will discuss that numerical. Tomorrow video, I will discuss that numerical, and after that we will start our chapter 3, that is motion. So write the question. Let the measurement of mass, let the measurement of mass of a body comes out to be 10.02 plus minus 0.01 gram, and its velocity 5.5 plus minus 0.01 1 meter per second. We had supposed this. So you have to find out the uncertainty or error, uncertainty or error, uncertainty or error. To find uncertainty or error in the measurement of momentum. You have to find out the uncertainty or error in the measurement of momentum. So this is for your homework. Try to do it, and I will discuss this question in next video, tomorrow's video, and after that we will start our chapter 3, that is motion in a straight line. Thank you students, take care, have a nice day.